we know that valence electrons are the electrons that play, like, determine bonding and stuff. Okay, those are the important ones. If you transfer an electron from one atom to the other, what type of bond do you get? If you transfer an electron, you get an ionic bond. If you share an electron, you get a covalent bond. All right. And why do we do this? What does every atom want to be on the periodic table? It wants to be a noble gas. That's the full shell, or the octet rule that you learned. That's the to have 8 valence electrons. That's the s2p6. So you filled the s orbital and the p orbital. That's what everybody wants to be. Hydrogen is an exception because it only has an s orbital. All right. So it only needs to gain 1 electron to form 1 s2. And then it's like helium. All right. So Lewis structures are what we're going to start doing. These show how the valence electrons interact or are distributed in the atom or the molecule or the ion to form a bond. Okay? So that's a Lewis structure. That's what we're going to learn to draw. Okay? These little dots up here are the non-bonding electrons. The bonding electrons are represented by solid lines, and every solid line represents 2 electrons. Okay? So, hydrogen wants 2 electrons, right? So if you look at the bond, there's 2 electrons in there. So this hydrogen's happy. There's 2 electrons in there, so this hydrogen's happy. Oxygen wants 8 electrons. 2, 4, 6, 8. So hydrogen's happy, or oxygen's happy as well. Okay, because they're sharing. Now this is a polar molecule, right? This is water. We in a Lewis structure, you don't represent the partial charges or anything like that. So you don't have to draw the partial negative, partial positive. We're not doing any of that. We're just drawing the bonds. Okay? So you don't need to do any of that. All right. What you need to know before you can start doing them is, what do the elements look like? So here's our periodic table. 1A, hydrogen, has 1 valence electron. This. Then you go across. It'd be nice if I had a periodic table right here. Over on the side over here is helium. How many valence electrons does helium have? It's got 2, right? Or 0, I guess, but we'll say 2. Okay? Because it's a noble gas, so it's full. You go down, then we got lithium. How many valence electrons? It's got 1, right? Because it's an alkali metal. You can go all the way down the alkali metals. Sodium would be next. It's got 1, and then potassium. We're not going to really deal with the other ones. Next one over are the alkaline metals. So here, let me just bring this up. So now we're going to do beryllium, magnesium, calcium. How many valence electrons do they have? They got 2. So beryllium, represent it like that. Magnesium, like that. Calcium, like that. 2 valence electrons in all of them. And then it's boron. So now we're here. Okay, we're not going to do the D block. We're only going to do S and P. Okay, to keep this straightforward. So boron is going to have how many valence electrons? Beryllium had 2. How many does boron have? 3, and then 4, and then 5, 6, 7, 8. So they just increase by 1 going across. So boron has 3. Carbon has 4. Nitrogen has 5. So there's 4. Then you start to pair them. Okay? So boom, the 5th one gets paired like that. Oxygen has 6. And fluorine has 7. And then finally neon is full. It's got 8. Everything wants 8 that we're going to look at. All right, and then going across the next level, so on the periodic table, now we're going to cross, we did sodium, magnesium, we're going to do aluminum, silicon, phosphorus, sulfur, chlorine. It's the same thing. They have the same number of valence electrons. So aluminum, silicon, phosphor, sulfur, chlorine, and then argon. Okay, you should be able to fill those in because they have the same number going across. So what we got? Okay. Oh, excuse me. So, how many valence electrons does fluorine and chlorine need to become like a noble gas? I forgot to do argon, didn't I? All right, there's argon.
I sent you the results.
Oh, okay, thanks.
No.
Really? Nice. All right. Fluorine and chlorine need 1 more valence electron to form a noble gas. So they have 7 valence electrons. Therefore, they'll form 1 bond. Okay? Because 1 bond gives them that extra electron, and then they're like a noble gas with 8 valence electrons. Oxygen and sulfur have 6 valence electrons. So how many bonds do they want to form? 2, because they want to pick up 2 more electrons to be like a noble gas. So they'll form 2 bonds. What about nitrogen and phosphorus? 5 valence electrons. How many electrons do they need? They need 3. Therefore, they like to form 3 bonds. And then carbon and silicon have 4 valence electrons. Therefore, 4 bonds. This all has one big caveat. Usually. Okay, there's always exceptions. All right. So usually they do this. All right. Most of the stuff we're going to look at, unless it's specific things, which I'll tell you, they won't. But for the most part, they do. Okay. Are we okay with that? Does that make sense? All right. Ionic compound. So when we do an ionic compound, Metal completely transfers the electrons. So if we have sodium, it's got its 1 valence electron. We react it with chlorine, which has its 7 valence electrons. Okay? And because you just did your test, you know that the En, the delta En, would be greater than 1.7, so it's an ionic bond. So this electron gets fully transferred there. So what happens is you get sodium plus, and Cl has picked up the extra electron, which is now 8. Sodium's still 8 because it's gone backwards, it's given up that extra electron. It's a negative charge. And it's the positive and negative charges that hold this bond together. Okay? But they are separate. That's a Lewis structure for an ionic bond, because that's what an ionic bond is. It's two separate ions that are attracted to each other because of the positive and negative charges. All right, covalents are more interesting. So, covalents, electrons are shared to fill the outer shells, all right, to be like a normal gas. So, if we're going to do HCl, hydrogen has its 1 valence electron. Chlorine has its 7. It wants that electron, but chlorine isn't strong enough to pull it from hydrogen. Hydrogen's like, I'm not giving it up. I'll give you most of it, but I'm not going to give up all of it. So what happens is they share it. So you get HCl. Each of them donate an electron to form a bond, which is the solid line. All these other electrons on chlorine are not involved in the bond. So they're still there. So we still have to put them in. So they look like that. Okay. So then if you're counting, because what you do, we'll go through how to draw these in a bit, is you check to make sure everything is happy. So hydrogen wants 2 electrons, right? Because hydrogen's here. It needs 1 more electron, and then it's like helium, which is S2, so it's happy. Chlorine wants the extra electron to be like argon. So we count. And we go, all right, hydrogen, there's 2 electrons in that bond, right? Because that's how the bond is formed. They each donate 2 electrons. So hydrogen has 2 electrons, counting the bond. Hydrogen's good. Then you look at chlorine. Chlorine's got the 6 electrons on the outside plus the 2 in the bond, which gives it 8 electrons. So chlorine is happy as well. Does that make sense? So because they're sharing, they both share those electrons, and then chlorine's like, I got 8 electrons. Hydrogen's like, I've got 2, so we're happy. Okay? So that's a Lewis structure for a polar molecule. If you do Cl2, it's even a little easier. So chlorine gas plus chlorine gas. They each want 1 more electron, so they share these 2 electrons. Whoops. Get shared, and you get chlorine bonded to chlorine, but all the electrons on the outside are still there. So boom, boom, boom. So now each chlorine has 8 electrons because they have the 6 electrons here plus the 2 in the shared bond. All right. sometimes you can share more than one electron. So oxygen, if you remember, has 6 electrons. So it look like this. Each one wants 8. So it needs 2 more electrons. So oxygen's going to form 2 bonds. And what it does is it shares this electron and this electron form 1 bond. But then this one and this one form another one. So what happens is you get oxygen I'm going to draw an intermediate sort of step here. So these 2 electrons form this. Actually, I'm going to do it the same color. And then red. There we go. So the 2 pinks share, and the 2 reds share. And because you're sharing the electrons, that is an actual bond. So we represent it with a line. So we get a double bond. And you have so it's 4 shared electrons. Each bond has 2 electrons in it, and there's 2 bonds, therefore it's 4 shared electrons. But the same thing, if you count them up, the octet rule still applies. It's 2, 4, 6, 8, 2, 4, 6, 8. So each oxygen is happy. Okay. How many bonds does nitrogen want to form? It wants to form 3 because it has 5 valence electrons. So it needs 3 extra electrons. Each one needs 3 extra electrons. So these share, and these ones share. So you end up with something that looks like this. And because it's 3 pairs being shared, we form a triple bond. So you get the triple bond. 6 shared electrons. All right. Are we okay with that? Okay. So, how do you determine the structure? Okay. ABN, AB subscript N. Usually the first atom will be in the center. Okay. So ABN would look something like A, and then the B's coming off of it like that. Now, how that's actually arranged in space, we're going to look at that probably in the next couple of days. But for right now, you could draw it like that. You could draw it like that. All right. Everything's sort of different. So NH3, the nitrogen's at the center. The hydrogens are off to the sides. That is correct. If you drew it like this, that is correct. Okay, there's actually a lone pair of electrons. I'm going to put them on, but we'll talk about how to do that, how to figure that out later. Okay, but those would be the same structure. Okay, NO2, you're going to get to the point. So N's going to go in the middle, oxygen out to the side. So if it's 2, usually it just goes linear. It's called a linear molecule. It would look something like that. But we know that oxygen wants to form 2 bonds. I'll just put that one there, even though nitrogen doesn't really like forming 4. It would be a charge, but that's okay. So it would be linear like that. Okay? All right. You need to remember this. So the halogens, all right, fluorine, bromine, chlorine, iodine, 1 bond. It's called the chalcogens. I'm not going to ask you that, and I think there's supposed to be an H there. So that's oxygen and sulfur, usually 2 bonds. We'll look at the exceptions. Nitrogen and phosphorus want to form 3 bonds. And carbon and silicon want to form 4. But like I said before, usually there are exceptions to everything. Okay? Most of the stuff that we're going to look at are going to follow those trends. If there's specific ones I want you to know, I will point those out to you. Okay? All right, are we ready to try Lewis diagrams here? We'll do a couple and then we'll pick it up tomorrow. Okay, how to draw a Lewis diagram. First thing, which isn't on here. So write this down. First, check to see if it's ionic. How do you know if it's ionic? How do you check? The electronegativity difference. So delta En is greater than 1.7, right? If the difference in electronegativities is greater than 1.7, it's ionic. If it's ionic, we'll come back to that in a sec. So like KBr is ionic. It gives up the electron. So the Lewis structure, potassium gives up its electron and bromine will take it. That's the Lewis structure for an ionic compound. Okay? It's complete charge separation. There isn't an actual bond. What holds them together is the charges being attracted to each other. Magnesium chloride is ionic. All right? Magnesium has 2 electrons. Chlorine has 7. Like that. So magnesium, I don't know if it gives it up. Chlorine rips those electrons away from it, and you get +2 for magnesium because it's lost 2 electrons. And then chlorine has gained the 2 electrons, or the 1 electron. So it becomes a negative charge. And it's the negative and the positive charges being attracted to each other that forms the bond. Okay, so your first step is always check to see if it's ionic. If it's ionic, that's what the Lewis structures look like. Okay? If it's not ionic, then it's covalent, and then you follow a different set of rules. Okay, does everybody have that? We're just going to go through like one or two examples here, and then we'll pick it up tomorrow. All right. Okay. If covalent. Count up the total number of valence electrons in the molecule of each atom. That's your first step. If you have ions, add or subtract the ions. So if you have an anion, which is a negative charge, you're adding electrons to it. Okay? If it's a cation, which is a positively charged, you subtract valence electrons. And we'll do a couple of examples of those tomorrow. Determine how they're connected. So that's kind of what the atom in the center and then the atoms spraying out from it. Draw the arrangement and connect the central and perimeter atoms with a bond. Use the remaining valence electrons to complete the octets. Okay, we're just going to go through this and practice it. We'll do 2 examples and then we'll pick it up tomorrow. All right, carbon. This is called carbon tetrachloride, CCl4. How many valence electrons does carbon have? It's got 4. Okay, if you're not sure, if you go to your periodic table, start counting from here. 1, 2, 3, 4. Okay, so it's got 4 valence electrons. So carbon's got 4 valence electrons. How many does chlorine have? It's got 7 because it's 1, 2, 3, 4, 5, 6, 7. So it's got 7. But how many chlorine atoms are there? There's 4 of them, right? So you have to multiply that by 4, which is 28. 28 and 4 is 32. There's 32 valence electrons that we have to account for here. Okay? That's your first step. Now, first atom is usually the one in the center. So carbon is sitting in the center. The chlorine, there's 4 of them. So you're going to equally distribute them around. So it'd be 1, 2, 3, 4. And the chlorines would look like this. And the thing about these is the more you do, the better you get at doing this. Okay, and you'll just start to know. So we have to do some practice. Okay, now, how many bonds? Then you ask yourself, how many bonds does carbon want to form? It wants to form 4 bonds, right? That's from here. Carbon. It's only got 4 valence electrons. So if it gets 4 more, it becomes 8 and it's happy. 4 bonds. Or you could look at it as on the periodic table, carbon's here. If it forms 1, 2, 3, 4 bonds, it's like neon. Okay? So carbon wants to form 4 bonds. So is carbon happy right now? Just carbon. It is, because how many valence electrons does carbon have? Each bond is 2 valence electrons. So that's 8. Okay. So carbon is happy with 8 valence electrons. That means we had 32. We've accounted for 8. 32 minus 8 is, I can't do math. What's 32 minus 8? 24? 24. So we have 24 left. Okay. I have to distribute those around the chlorines. So how many does each chlorine get? 6, right? 1, 2, 3, 4, 5, 6. Okay, so now how many valence electrons does each chlorine have? It's got the 6 pink ones plus the 2 from each bond, right? So 6 plus the 2 is 8. So is chlorine happy? All the chlorines are happy because they filled their octet rule. Okay? So that's the valence structure, or the Lewis structure of carbon tetrachloride. All right? We're going to stop there and we'll pick it up tomorrow. Okay?